All right, so this is my second Leetcode contest, and I solved three out of the four of the problems. Looky, this is probably an easier contest, except for the fact that number one was a really stupid question. Number one is an example of to be honest, it's just an example of make sure you think before you code. And it's really toxic that it's a number one because most of the times people are just in a rush to do number one, and so you don't really think about edge cases. But in this case, that's what this problem is about: edge cases and stuff. So whatever. So for this problem, it's a really straightforward question. There's no it's like an implementation problem. So I'll just show you how I implemented it. I actually found so the first time I did it, I had a really bad implementation, and so I didn't really. So then I had to come back after I did two and three. But yeah, it's my implementation, which is low key a pretty clean implementation if you ask me. I'm not gonna lie, it's pretty clean. But what I do is yeah. So make sure you read this. I didn't read this at all. So yeah, make sure you read this. So it only consists of spaces and characters. So the idea here is that it's really stupid. You have to cut leading spaces, and then you have to trim the back, right? So just strip the leading spaces and trim the back, so you don't have to deal with basically any extraneous spaces. It's kind of stupid. And then after, you just start with a hashtag, and then all the words are gonna you can just split them by spaces. But here's the thing where you have to be clean. So you go through all the words, and then if it's the first one, the idea is that all the letters will be lowercase, but actually check if if the length of the word is greater than zero. Just be objectively sure that it's greater than zero, right? And then do that, right? That's just for there could be I don't know, maybe there's nothing at all in words at zero, or I don't know, but that's just be objective and just add it, right? After that, it's just every all the remaining words, the first letter should be capitalized. So what I did was okay, let me check if it has a greater than zero length, and if it does, then I'm gonna capitalize the first word, and then after let me check if uh it has greater than one character, right? And then everything else just goes to lowercase. And that's pretty much it, right? Because it could have one character. So if you do substring one, you have to assert this if statement, and then after, you have to, it's only 100 characters. So 0 to math.min, 100 out.length. But yeah, that's really it. Another thing is that there's only 150 words. So yes, I know that string concatenation is n squared, because Java copies a string again after adding it. It's not like string builder where you can just append on a previous build thing. So yeah, this isn't really efficient, but the point is if it's 150, then this is a clean implementation. All right, so next question. Yeah, this question wasn't hard either. It was a pretty standard question. My only thing is I usually yeah, I have a mod template which I recommend you get for these mod problems, because when you add stuff and subtract stuff in modulo, it just makes your life easier if you already have a template for this stuff. So that's a recommendation. But yeah, but the idea is that we want to find the amount of special triplets, and at first I thought it was the triplets had to be x and then x over 2 and then x over 4. But this is actually an easier problem because you realize that the middle number anchors the other two numbers around it. The middle number, the numbers that are around the middle number are just the double of the middle number. So what you can do is you can literally just fix the middle number, right? So if you fix the middle number, then you need to find the amount of numbers before the mid. So for everything you're gonna fix the middle number, then find the amount of numbers before it that are double the middle number, and find the numbers after it which are double the middle number. And this is very easy. You can just do a prefix. You just need to keep track of the prefix frequency and the suffix frequency. And the idea is that you can keep track of the prefix frequency as you go through the numbers, but for the suffix frequency, just use subtraction. Use subtraction to find, you can find the entire frequency and then just subtract it out. But there's one edge case, right? That's just what Leetcode likes to do through edge cases, right, or whatever. So in the case of subtraction, if x is equal to 0, right, when you subtract it, you don't want to count that one, so just subtract 1. For example, if I'm on here and the number I'm fixing is 0, and I'm gonna subtract like the prefix frequency from the entire thing. Like I don't want to count zero, so I just subtract one, right? And so that's pretty much it. And then for this question, yeah, this one's also trivial too, low key, much easier than one. And low key, I'm kind of annoyed because like I didn't really spend time on two and three. Um, it was mainly just one that was stupid, but like I don't really care. Second contest, right? Who cares? Okay, so the idea here is basically, yeah, you need a subsequence of length m. So the idea is that like if you start on, let's say you fix the start point, right? Then you basically like have to start on this index or more as your last one, right? This is like you go through each element, you fix it as the first number, right? And then for the last number, you know that like you can only take from this number and so on to n as your candidates for the last number. This is because of the condition that the subsequence has to be like greater than m. And so the idea is that like we don't care what's actually in the subsequence. We just care that like it ends such that it satisfies the condition that there's at least m elements, right? If I end on like something over here, well then like this is not sufficiently enough, right? So the idea is that like you just keep track of like a suffix min. You keep, since there's like negatives, you keep track of suffix min and suffix max, because obviously like the idea is that like um well, the idea is that like you only need to multiply the current number by the extremes. Everything else in between doesn't matter. So I just multiply the current number by the extremes, uh, and then I just take the maximum across all. And yeah, that's pretty much it. Number four, I'm gonna probably upsolve, and I mean, we'll look into it, but I mean, whatever. Yeah, that's pretty much it.